Policies can be organized into multiple types depending upon how they are enforced. Within the lifetime library, three mechanisms are provided for when and where policies can enforce collection properties. The first mechanism is a policy enforcement point. The original version of the data grid, the storage resource broker, hard-coded constraints into the software. This ensured consistency across a distributed environment. However, the United Kingdom data grid required three incommensurate policies. They wanted a collection where all deletions would be disallowed, even by the system administrator. They wanted a second collection in which the system administrator could delete corrupted files. They wanted a third collection in which collection creators could delete files at will. In the IROD's data grid, this was handled by removing the software coded constraints on deletion and replacing the code with a policy enforcement point. When this location in the code is encountered, the middleware consults a rule base to determine which policy should be enforced. A check can be made on the user role and the collection name to determine whether deletion is disallowed. Management policies are usually enforced at policy enforcement points. The second mechanism is a rule that has been queued to execute periodically. The rule engine checks every minute for whether a rule should be executed. Operations that require interaction with slow devices, such as a tape archive, are usually queued for later execution. Reports that need to be created each week are queued for automatic generation. The queued rules are saved in the metadata catalog, ensuring that they will continue to be automatically checked after a system restart. Validation of assessment criteria is usually done through a periodic rule. The third mechanism is to run a rule interactively. Rules are written in a rule language and saved as a file. The file can be deposited into the data grid, accessed and executed through interactive commands. Examples include checking the status of the system, or applying processing steps to selected files, or repairing a detected problem. Interactive rule execution is usually applied for administrative functions. Note that different forms of a rule can be made. Usually an interactive version is created first. Once this works correctly, it is then either submitted as a periodic rule or inserted in the rule base for automatic application at a policy enforcement point. Within the data grid middleware, there are specific points in the code where actions can be trapped. When the policy enforcement point is reached, the data grid consults a rule base to find a rule that can control the action. The rule is executed through the IROD's rule engine. When the rule completes, control returns to the data grid middleware. This means that the control mechanisms are separated from the code that does the operations. Control over the operations can be dynamically changed by updating the rules in the database. There are more than 70 policy enforcement points within the middleware. In addition, each time new technology is added to the middleware, additional policy enforcement points are created to control the technology. The data grid can control each technology choice, control interactions with users, and control operations performed within the data grid. An external client-driven action may access multiple policy enforcement points. The creation of a copy of a file checks policies at 11 policy enforcement points as shown here. Note that each policy enforcement point is named starting with the letters AC for action. The policies may control the associated action or be applied before the action occurs, ACPRE, or be applied after the action occurs, AC post. The first three policy enforcement points in the list manage access controls. These are executed for every action applied within the data grid. The policy enforcement points control policies that are usually executed synchronously immediately after the action is initiated from a client. We use the term policy to denote a management process executed at a policy enforcement point. We use the term rule to denote the workflow that is executed by the rule engine. Thus, a policy controls the execution of a rule. Policies can submit rules that are delayed for execution at a later time. The rules are submitted to a queue. The rule engine periodically checks the queue for a rule to execute every minute. Rules can be set up to run only once or periodically multiple times, or for a set number of tries or for execution at a specific location. A standard example is the creation of a queued rule to replicate a file onto a tape archive. Since the process may take several minutes, by queuing the rule, the action can return immediately and allow the user to submit another action. A second example is a periodic assessment criteria, such as an integrity check performed each month. The assessment rule could verify the number of replicas, verify validity of each checksum, and verify presence of required metadata. Users can initiate rules from clients. The rules can be executed immediately or deferred for later execution or executed periodically. Note that the policy enforcement points still control the operations performed within the rule. Thus, if the rule workflow copies a file, multiple policy enforcement points are invoked when the relevant areas within the middleware software are executed. The intent of a policy-based data management system is to ensure that actions are controlled, no matter which client is used to initiate the action. The clients we will use include two types of web browsers, Cloud Browser and iDrop Web Browser, and a Unix shell command called irule. All three clients support invocation of a rule that is executed by the iRODS rule engine. A rule is written in the iRODS rule language and stored as text in a file that has a .r extension. The extension is important. The first version of the iRODS rule language stored the workflow text in a file that had a .re extension. Each rule can have input parameters and can generate output variables or files. Rules can query the ICAT metadata catalog to retrieve persistent state information, can access files within the data grid, and can invoke applications at a remote site. The rules will work in a distributed environment and can invoke processing at multiple sites. The syntax for a rule is simple. The first line contains the rule name. In this example, the name is my test rule. The workflow is contained within braces. Comments can occur anywhere, are preceded by a pound symbol, and are terminated by an end of line. The operations performed within the rule are encapsulated in microservices. Each operation instruction is terminated with a semicolon. This rule writes the message hello world to standard out using the microservice write line. A closing brace terminates the rule. All input variables are listed on a single line that starts with the text input. All output variables are listed on a single line that starts with the text output. To print standard out to the screen after interactive execution, the output line contains the text rule exec out. Please take 7 minutes to complete the exercise for Module 5. Write a paragraph on a data management application that is important to you. Define the types of policies that will be important for your application. Will you need automatic enforcement, periodic execution, and interactive execution? Please load your paragraph into the lifetime library in the subcollection class-INLS 624 by the end of today's class.